let's briefly talk about why is still why is data science required for us? Why is that we still looking at um, data science as a very niche field, right? To give you a brief history of data science, it all started in the year 2012. There's a professor at Harvard. His name is Thomas H. Davenport. Uh, this Thomas wrote a lot of books on data analytics, data science. He is the first person who coined this term called as data science. Before that, it was referred to as analytics or advanced analytics, right? So that the work that we call as data science today did existed before 2012, but with a different name called advanced analytics, right? In 2012, when Thomas H. Davenport wrote an article in Harvard Business Review claiming that data scientist, the sexiest job of 21st century, that article made data science popular and created a designation called as data scientist. Okay. Since then, since 2012, data science data science has been the most evolving field, and it has been the number one job in terms of number of jobs created across the globe, right? Many things. Why? The reason is every industry is going through digital transformation. Okay, if you are worried about digital transformation, what is this digital transformation? Like, let me give you an example. Few years back, when we have a problem with any of the business, we used to call them on the call center. There will be some fancy number, and you call them on the call center. And at the call center, you have to go through a lot of things. Like, first there is IVR menu, press 1, press 2, press 3, then you select something, then you try to complete what the IVR menu is trying to say. It's not going to solve your problem, so you want to reach out to the agent. So you ask, hey, I want to talk to the agent. Then again you will stay in the call for some time, then finally connect it to the agent. And there is a lot of unnecessary headache that as a customer we have to go, in spite of having problem with the business. Okay, of course we are facing the problem, but the problem is with the business, right? Now let's take the same thing today. If we have a problem, we don't call the call center, or we don't prefer to call the call center, even the call center exists, right? Take any consumer business like Zomato's, Amazon's, etc. They all have fantastic chat support. So you go to a chat window and try to put your thoughts in free text. Most of the time you get your response spontaneously, right? It's not a human being who is trying to answer you all the time. Sometimes it could be a human being, but it's actually a machine behind the scenes which is trying to answer you, right? So gone are those days. The traditional way of operating a business is no more acceptable to the customers, because if you remember the call center experience, you know how painful it is if you have to raise a complaint, raise a service request, and follow up with them. But today all of them is on your hand, in the form of a app in the on your smartphone, right? So that's what I'm talking about, digital transformation, right? Everything that needs to be done for any business, be it consumer business or be it enterprise business, all these things can be done with the help of a smartphone, with the help of apps. That's what I'm calling it as the digital transformation. And what it has led to is a whole lot of new problems. Now the companies is having tons and tons and terabytes of data. They don't know what to do with it. And if they have to provide such intelligent services to the customers, they have to use this data, they have to learn from this data, and they have to build tools and applications that can automatically help the customers, right? So that's where data science has evolved over a period of time, right? Even today, there is a significant mismatch between demand and supply in this industry. Since 2012, there is never a point in time where supply has overgrown the demand in this industry, right? I know there are tons of programs across the globe, from prestigious colleges to B schools to engineering colleges to professional certificate providers. There are a wide range of training programs in these areas: data science, machine learning, and AI, right? But still, there is a huge skill gap when it comes to expectation in the industry versus what people have as skill set that they have learned from these type of courses, right? So that's where I would say there is a shortage of skilled data scientists. I'm not saying shortage of data scientists, shortage of skilled data scientists as expected in the industry, right? So somebody could have very good theoretical knowledge, but they don't have enough practical implementation. Some of them can have practical implementation knowledge, but they don't have the depth of the subject that is required, right? So this is the biggest problem in this industry. And we, as a professional institute, we want to we want to reduce this gap. We want to nudge this gap to as small as possible. And that's why if you see our team, so our team has industry experts coming in from a wide variety of domains. That's another problem, right? So most of the time data scientists come from tech companies, big tech companies, right? They might have worked mostly with social media data, so they might have been very good with a particular set of applications, right? It's very rare you see a person who has done data science work in healthcare industry, in manufacturing industry, right? So that's why the students who get trained by these people, they also might not have the breadth. Like, hey, how do I solve this manufacturing problem using data science? How do I solve this healthcare problem with data science, right? So to provide that exhaustive experience, we have formed this team who consists of people from a wide variety of domains. Okay, and I don't have to tell you about this field. You might have been reading reports, you might have been following the internet, social media, where every day they talk about something. For example, generative AI is the new cool thing. How many of you heard this term, or how many of you have used this chat GPT? Has any one of you? You can just type in your answer or just raise your okay, at least I got a few responses. Yes, right. Everybody might have read about it or at least have tried it, right? Yeah. Chat GPT has become so popular, but has any one of you heard Gemini.ai recently? No, right? Many of you are saying no, right? Okay, at least one person says yes. Thank you so much, right? So Gemini.ai is the new cool stuff released by Google just a week back, right? ChatGPT was all over the place. Before Gemini.ai, Google had another competitor for ChatGPT, which is called Bard. If you haven't heard about it, that's totally fine, no problem about it, right? But Bard has a lot of challenges. It was not as good as ChatGPT, and that's why ChatGPT was like very, very popular than Bard, right? So to compete with ChatGPT, Google has worked on Bard and they have improved it, and they have released a new one called like Gemini.ai, and they claim Gemini.ai is much faster, much better than ChatGPT. In fact, I have tried a few things. What I have found is Gemini is good in some areas, ChatGPT is still good in some areas, right? But not yet that popular, but over a period of time, you might be hearing a lot about this Gemini.ai. Okay, so that's this industry. It has been growing and growing, right? So the number of jobs that are being created by this industry, either as a AI developer, as a machine learning developer, or as a AI user, right? Not everybody has to learn the complexities of machine learning in and out in order to become a AI user, right? But still, they have to understand how AI works. Where does AI come into the picture, right? But it depends upon the level of comfort where we have to go, right? So that's why in this field there are like many roles. It's not just that, hey, data scientist is like one single role. I'll talk about it more in one of the following slides. Okay, so the demand is growing and growing. From 2009, which was estimated at 2.8 billion, I think it was estimated to hit more than 100 billion by end of 2028 or 29. I'm not exactly sure, right? And it's possible because we have seen how AI has grown leaps and bounds in the recent years. Okay, I can actually skip this. Now, this is the part where I would like to spend a little bit more time on, because this is going to be very close to all of us. Now, who is this person called as a data scientist? Data scientists are the ones who have at least a very good, strong foundation in one of the key concepts called as machine learning. Okay, maybe let me use a pen and paper to explain this so that it would be easy to understand. So the foundational block of data science is machine learning. Okay, I'm trying to find my. Just give me a minute. Huh? So let's try to understand what is machine learning. I would try to compare this using software engineering, because I think many of you might be already familiar with software engineering. So comparing it with software engineering would make things easy. What happens in a software engineering, right? We have an input. I'm typically trying to explain software engineering with the help of programming. Of course, there are tools, all other things, but trying to simplify as much as possible. And we are given some requirements. Okay, hey, this is the requirement. Using this requirement, we are going to write a program. And this program has to generate us an output, right? So this is the typical software engineering process. Hey, for a given output, I need a particular output, and how to generate that output is given in the form of requirements. So we write a program so that will take an input and it will give you an output. Okay, now let's see what machine learning is. Machine learning is slightly different. Okay, we have a input and I have a desired output. Okay, what is this desired output? Let's say I am feeding in a image. This is an image. Okay, and this image contains a apple in it. This is the input, and my desired output is the machine should be able to recognize and say, hey, this is an apple. There is, let's say, another image, and this image is orange, and we say, hey, it should be able to recognize it as a orange. Okay, so we give both the input and the desired output as inputs here. What we give as a requirement is, hey, try to find out some logic to generate this output. Okay, to generate this output from this input, and give me that logic as the output, or give me that knowledge as an output, right? So in a typical comparison, let's try to start this comparison with human beings learning. Okay, let's see what learning means. Learning means when we are at school, let's say the teacher shows us, I'm very bad at drawing, let's say, shows us an image and says, hey, this image is apple. Next day, we come to school and teacher again shows us, let's say, another image or another fruit, and asks us, what is this? Don't you think many of the students in the class will say, hey, this is apple, I know you taught us yesterday, right? Simple way of learning, isn't it? Do you all agree with me on that learning part?
Yes.
Okay, right. Now, the question is, yesterday, teacher has shown us a different apple, and today, let's say this is a Shimla apple. Okay, and today what teacher has shown us is a Fiji apple. Okay, do you think these two are going to be exactly same? A Shimla or Himachal apple and a Fiji apple? No, they are different. They look different also, but still many of the students has recognized it as the app, as an apple, right? So it's not memory. Don't get confused that, oh, yesterday they have seen this image, they memorized this image, and today they have seen this image, and that's how they are trying to recognize it as an apple. No, right? Though these two are two different apples, human brain has this capability of learning. What human brain did here is, without we realizing, when we saw this image of an apple, we created some sort of knowledge in our brain. That is like, hey, what is the shape of it? What is the color of it? What is the texture of it? What is the size of it? If they have touched it, how does it feel? A lot of these is automatically created and stored in your brain. So next time when another apple is given, we try to process it in the same form. Is the same shape, is the color, is the texture, is the size, or the if the feel of it, they're all same, right? Though they are two different apples, shape may match, color may slightly mismatch, texture would exactly match, size will match, even the feel of it would match, right? One of the parameter that we are looking at is not matching, but many of the other parameters are matching. And that's why we say, oh, hey, this is an apple. I am very sure this is an apple, right? So this is actually what we call as learning, and that's what human brain does, right? Now, we want that to be replicated by a machine. We say, hey, this is an apple. This is the image of an apple, right? And this is what you should tell me if I show you an image of an apple. So learn how you can recognize this as an apple using this image. Keep that learning, which is the logic or the knowledge. Sorry, can you hear me now? Am I audible?
Yes,
Yes, sir.
Okay, because my other Bluetooth headset has died, so that's why. Right. So next time you have this knowledge, Now I will give you an input, which is this image. Let's say this time I am giving you an image with mango in it. I know it. Now I'm expecting you an output. I'm expecting an output from you to say, hey, is this an apple? Yes or no? Since it's a mango, you should tell me that, hey, it's not an apple, it's no, right? So learning from data and using that learning, using that logic to make decisions into future is what in simple terms is called as machine learning, which is the fundamental block of data science. Okay, is the term called machine learning clear for everyone now?
Yes, sir.
Okay, I'm giving a very simple example, but in context, learning could be very complex in some scenarios. But to just get us started, we are starting with this. Okay. Now there is another field which is a subset of machine learning called as deep learning. Now, hey, what is this deep learning? In machine learning, see, machines can't just randomly learn like human beings, right? For example, let's say if someone asks us, what is your name? We respond with our name. Hey, my name is Sagar. Like, how do we learn that? In school, we have been taught grammar. Uh, we have first been taught how English alphabets look like. What are these alphabets? Then words, then vocabulary, then grammar. That's why we understand this statement when someone asks, what is your name, right? But don't you think we have to try to help the computers also understand the same way, but not exactly same way, but in logic, it has to understand an English statement, it has to understand vocabulary, it has to understand grammar, right? It's not going to be so simple. There is definitely a lot of complexity in it, right? Learning how to recognize an image, in this case, Apple, versus learning how to answer an English question is way too different. From the school days, we have been taught as English, so we know. From the school days, been we have been taught us how to recognize something from images, how to remember faces, how to recognize faces. So that is a natural capability for a human brain, but not for computers, right? So depending upon what type of task we are performing, learning will change. If we are dealing a lot with traditional data, when I say traditional data, it's called structured data. Let me call this as a structured data. So what is this structured data? Hey, I want to predict who will default my loan. Many of you might have heard something called CIBIL, credit score, right? So a CIBIL or a credit score is nothing but this. When someone applies for a loan, it gives us a score which tells us, is this person safe to provide a loan? Or is this person risky that we don't have to provide a loan? It's like predicting who will default the loan, right? So typically for us to learn this, we give input like, hey, what is the age? What is the salary? What is the income? What is the loan? How is the previous loan payments, EMI, etc. So all these are our inputs. And then we are trying to say, hey, for this customer, the desired output is this person has defaulted or this person has not defaulted, right? So we call this as example. So if you look at this, person number 1, age is 22, gender is male, loan amount is 1 lakh, EMIs, existing EMIs is 10,000, salary is 50,000, something like this. And if this person will default, if this person has defaulted a previous loan, yes. Another person, 28, female, 2 lakhs, loan amount is 5 lakhs, something, this person has defaulted, no, right? So these are called as training examples, right? Now for this person, you have to say, yes, this is the desired output. For this person, you have to say, no, this is the desired output. So I'm giving this examples, training examples as input. You learn. How do you learn? I don't care. You give me the logic or you give me the knowledge, right? So based on this knowledge, in future, if I give these inputs, you have to tell me whether this person will default or not, right? So this data is looking like a tabular data, like it is looking like an Excel file, or it is looking like a table in database terms, right? So when we have data like this is called structured data. But in this case, like trying to recognize an apple or trying to answer this question, hey, what is your name? We are giving this as an input. And the answer is, hey, my name is XYZ. So this is the desired output, right? So this is the input and this is the desired output. Now, try to learn and store the knowledge. This is altogether a different problem. In this case, the input and the output both are text. So this is a text problem, or it's called as unstructured problem, right? An unstructured problem, there are a lot of things. One is images, videos, text, log files, a lot of them, right? Learning from this type of data is quite complex. It's not as easy as what we think of as structured data, right? So to learn from this type of data, we need a very separate set of algorithms. So for structured data, we have certain algorithms that can help us learn from structured data. Basically, these algorithms are derived from the concepts of statistics, data mining, a lot of different things, right? But when it is very complex problems like text and images, unstructured data, learning from them becomes very complex. So we need a very sophisticated set of concepts called as neural networks, right? You might have heard this term called neural networks or neurons in your school days or even in college days, right? So this is deep learning is all about neural networks, like how we can use artificial neurons to learn these type of problems. Here, how we can use concepts of statistics and data mining to learn these type of problems, right? In a nutshell, these two, machine learning and deep learning, which is a subset of machine learning, forms the core skill set, the fundamental skill set of a data scientist, right? Now, if someone says data scientist, they might be using machine learning, especially the traditional machine learning, which came from the concepts of statistics and data mining. But if someone says, I am a AI engineer, they are talking about this area where they are a deep learning expert. They are either using images or videos. This is one field, like self-driving cars. So it is all about images and videos, right? Or using text, which is your chat GPTs, chatbots, Gemini, etc., etc. Right? So these two forms the foundational skill set for data scientists, AI engineers, right? So that's going to be the core concept which we have to learn if you are aiming to become a data scientist. Okay, now that I have explained what is the fundamental skill set for a data scientist, there is no restriction on who has to become a data scientist. Any person, irrespective of what you have done in your undergraduation or post graduation, you can become a data scientist given that condition you learn machine learning or you learn deep learning, right? It's to learn deep learning, you should have very strong understanding of machine learning. That's why I keep on saying deep learning is a subset of machine learning, right? So you can't just directly jump into deep learning unless you understand the concepts of machine learning, right? Anyone who, you can be a working professional, or you can be fresh grad out of college, or you may not be working in a technical role, you might be working in a functional role like sales, marketing, right? Everyone can get benefited by learning machine learning and AI, right? Today, almost every field across the company leverages machine learning or data science in order to do their job in a better way, right? Imagine how ChatGPT has really helped us in writing documentation, right? Before ChatGPT, everyone was struggling to write documentation. ChatGPT made our life much easier. I don't really have to take the pain of it, right? So that's where doesn't matter what your current role is, you can still get benefited by AI. Okay. Hmm. Uh, why analytics path? So you know that what is that we are trying to do. Sorry, what is that we have to learn if we have to become a data scientist or a AI engineer? What we offer from analytics path, right? So we have a very well designed curriculum by industry experts. I have introduced you my team at the beginning itself, right? Each one of them has been in this field for quite some time, some of them more than 10 years. We have seen how this field has evolved over a period of time. Whatever that we have learned over the years, how can we cater that to our students in the shortest possible time, right? So that's our motive, right? So another big big advantage of choosing analytics path is everything is a live class, like how I am conducting this webinar today, how I am using this blackboarding to explain things, right? So data science and AI is a field where there is a lot of mathematical concepts too, right? Unless there is a good blackboarding experience where we try to explain things with the help of a pen and paper, like what you are saying, it's difficult to understand, right? So the interaction with the trainer is critically important to understand this. Okay. Um, much different than learning from recorded videos. So actually we encourage all of our students to attend live sessions. Don't miss even a single session. If you miss one or two, yeah, you can go and watch the recorded video of that particular session, but it's always good if you can make it to the live session, right? So 220 plus hours of content, 18 plus projects as we go through the content. So our content has been divided into modules, and for each module you will get 2 or 3 in a real world use cases to work with, right? We have more than we say 3 plus, but right now we have 5 plus capstone projects delivered by our faculties, right? So these capstone projects are the industry projects that we have solved in the past. Now we want to share it with you so that you can get a hang of what is the scale of the problems that we solve in the industry. And this also gives you an opportunity to work with a hands-on problem at an industry scale, right? So the capstone projects is very critical in order to uh, test your knowledge, right? So it's easy to sit in a class and listen, but it's very difficult to understand the concepts and apply them in the real time. Okay, what are the tools that we are going to use, and what are the technologies that we are going to learn, right? For any software engineering or a machine learning or a data science work, it has to be done through programming. And the most sought after programming language here is Python. So this entire course is going to be taught in Python, right? Some of these can be done in another programming language called R also. That's why I listed it. But maybe if you asked me a few years back, I would say, hey, it's good to learn R also, but today, no, R has like faded out. It's all Python, 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 right? So Python is going to be our go-to programming language, right? So don't worry if you are not familiar with programming before, or if you haven't done heavy lifting programming before, right? We don't expect people to learn programming language and come to this course. So that's why the first module of this course begins with introduction to Python as a programming language. I want to make one thing very clear here. Python is an ocean. There is no limit to Python, right? So Python can be used as a pure pledge object-oriented programming to develop games, to create web applications, to data science, right? So it's a very vast area. What we say when we teach Python here is you will be learning Python in the context of data science. Hey, if you have to be successful as a data scientist, what is the Python? What is the important libraries in Python? What is the important programming part of Python that we have to learn in order to succeed as a data scientist? That is going to be the focus. Okay, so we will be focusing on that, right? So if you say, hey, can I apply for a web developer after learning Python here? My answer would be no. Our intention is to make you data scientist, not a web developer, right? Yes, but Python can be used for web development. That's what I wanted to make it very clear, right? And Python is our programming language, but data comes in different shapes, different sizes, unstructured, semi-structured, structured data, etc. Right? So we would be dealing with a lot of wide variety of data sets, and sometimes the data can be on Hadoop also, right? So when the data is on Hadoop, generally when the data is on Hadoop, it is termed as big data, right? But big data is a very different field. I don't want to get into big data, right? All I want is to understand how do I take the data from big data and do machine learning or data science on it. This is where Spark comes into the picture. So we use something called as PySpark, which is Python wrapper built on top of Spark. So Spark can help us to fetch the data from the big data systems, and we would be able to do machine learning directly on big data. So that's why Hadoop and Spark is mentioned there, but don't mistake, this is not a big data course. So we are not going to teach you everything in Hadoop, because Hadoop and big data falls into another area called data engineering, and we are not here to become data engineers, right? We want to become data scientists. We want to become ML experts and AI engineers. Okay, so though it's mentioned because we just want to get familiar with it so that we use Spark to fetch the data. Okay. The other things that are mentioned over there, like TensorFlow, Keras, don't worry about them. Those are packages, those are libraries on top of Python that would help us to perform all these machine learning, deep learning tasks, right? So don't even worry. The reason I have put them over there is a few of you might have had previous experience either working with a data scientist or interacting with a data scientist, and they would say, hey, I'm trying to build a image classifier. I use TensorFlow, I use Keras, I use PyTorch, I use Caffeine, right? Now, there is no end to it. There are like tons and tons of packages, right? We can use Caffeine, we can use PyTorch, we can use Keras, we can use TensorFlow, right? But in a course like this, it's impossible to cover all those packages, right? In general, in the real world, either it is TensorFlow, which is given to us by Google, thanks to Google R&D team and engineers at Google. They have been using TensorFlow for quite some time, but then maybe at some point in time they have realized, oh, okay, and I think now is the time we have used TensorFlow enough. We should be start working on another 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 way of doing things. So let's try to open source TensorFlow. Let's give it to the community. If whoever wants to use TensorFlow, let them use it, right? So they gave us TensorFlow. Um, Facebook, Facebook thought, oh, why only Google? You think you are smart? You think you are contributing to the society? We can also contribute to the society. We have been using something called as PyTorch. So I'm going to outsource my PyTorch. So anyone who wants to use it to build their own applications in deep learning, they can too, right? So Facebook has given us PyTorch. Now, in the industry, it's difficult to use both, right? Some of them prefer PyTorch, some of them prefer TensorFlow, right? So here in this course, we would be using TensorFlow, not PyTorch, right? So to give you that, hey, are we going to use TensorFlow? Are we going to use PyTorch? There's a common question that I get. So that's the reason I put them explicitly over there saying, hey, we will be teaching this course through TensorFlow. It's all about package, right? Which you are comfortable with. Both TensorFlow and PyTorch can do the same thing in a different way. People are comfortable, and usage in the industry is heavy for TensorFlow. That's why I put it. All these use cases that I have been talking about, the 20 plus use cases, they are going to give you the breadth of applications of data science across different industries. We have use cases built right from healthcare, insurance, manufacturing, to aerospace, everything, right? Social media, we would be using a lot of social media data because that data is freely available and accessible to us. So it's a great way to learn from the social media data. Okay, so that's what we offer. How do we generally train? Uh, Everything is going to be a live class like this. Uh, the classes would be either on weekdays, mornings. It's actually 7 to 8:30 because morning all the way up to 9 it would be difficult for people to start and go to their job, right? So we changed the timing from 7 to 8:30. And in weekends, right now we are not starting any weekend batch right away, but if it happens on weekends, it's typically like 4 to 5 hours with breaks in between. It can start anywhere at 9 a.m. and go all the way up to 2:30 3:30 p.m. Okay. To give you more details, I think I have Ram here. Ram, if you want to share more details, please take over. Okay, looks like Ram is not able to unmute himself.
Hello.
Yeah,
Hello.
Ram, we can
Yeah.
hear you now, please.
Yeah. Hi everyone. I'm Ram. So I look after the admin and management part at Analytics part. Apart from that, Sagar has given the introduction in the beginning. Like I have 18 plus years experience into business intelligence and data warehousing side and reporting on reporting tools. So coming to this program structure. So we are going to start with the online batch. So this will be a totally online batch that we're going to start from 21st of December, which is morning 7 a.m. to 9 a.m. It's a 2-hour session, Monday to Friday. Okay. So this will be a 5 months, approximately 5 months session, which will be almost 200 plus hours training content that we are going to deliver. Okay. So you need to first reserve your seat for the batch. So the total course fees is 60,000 inclusive of GST. So 5,000 is for reserving your seat. Then 25,000 is the first installment before your batch starts. That is by Wednesday. And 30,000 is the second installment after 1 month. So altogether the total fees will be 60,000 including the GST. Okay. So our council will give you a call back, and if we do not have your number, because some of them have joined with different names, so you can call to our counselors and you can talk to them. Okay. Yeah. Any technical questions? Sagar will be here to help you out.
Thank you, Ram. Now let's open for questions. I think Ram, are you or someone from the admin team can actually post the details, phone number, and the email IDs in the chat so that people can take note of it. I don't have that in the Prezo.
Sure.
Thank you. Yeah, let's open for questions. What's on top of your mind? See, when it comes to Power BI, in this course, we have a module called data analytics and data visualization, right? As a data scientist, our goal is to build predictive models using machine learning. But before we go and build predictive models using machine learning, it is essential for us to understand the data thoroughly. And to understand the data thoroughly, we use a lot of data visualizations, right? So that's where visualization tools like Power BI, Tableau, ClickView comes into the picture, right? But as a data scientist, we don't rely on these tools like Power BI, Tableau, ClickView in order to build those visualizations. Python has very good packages like Matplotlib, Seaborn, which can produce very good plots, and we try to understand the data using that plots itself. Where Tableau, Power BI, and ClickView comes into the picture is if we have to create a dashboard, and a very fancy dashboard, not a simple plot or chart, and manage it, like who should have access to it, who should not have access to it, what to show, what not to show, then the tools like Power BI, Tableau comes into the picture, right? Typically, those dashboarding all done by BI people, business intelligence people, right? So this is not a business intelligence course. Having said that, when we actually go through the data visualization module, we will teach you how to build all those visualizations using Python itself. But there are there are a few sessions that we cover on Tableau as well. Like if you have to build those charts on Tableau, how to do it. But this is not a typical BI course where we cover the BI tools. Okay, this is a machine learning course. Okay. Visualizations is like a very minuscule part of what we do. Yeah, any more questions? Thank you, Rahul, for the question. I hope this webinar is informative for you. At least I think you might have got an understanding of what is this machine learning. Okay, to admin, are there no offline classes? I don't think so, but our admin team will reach out to you if there is any. Okay, good. Thanks for asking that, Avani. Will Azure gets covered in this course? Okay, I want to clear one thing here, right? Our go-to programming language is Python. We can try to develop all of this on our system. Like I can use my own laptop to do all of this, especially while learning, right? But in industry, because the volume of data they handle and they have to store this data for years and years together, and sometimes due to the large size of the data, they need heavy infrastructure to build all these things, which might not be sufficient enough to do it on laptops and all, right? So this is where infrastructure comes into the picture, right? So we need heavy infrastructure if we have to deal with gigabytes and gigabytes of data as our training input. Now, the question is, are we going to buy a huge physical server, or we going to cloud service providers to get that infrastructure? Like cloud service providers in this case is AWS, Microsoft Azure, GCP, Oracle Cloud, Databricks, a lot of them, right? Industry is slowly moving away from physical infrastructure because it's heavy in maintenance, upfront cost, lot of different things, right? So it is going to be one of these, either AWS or Microsoft Azure or GCP, Google Cloud, or Databricks. These are the four popular clouds that I am aware of. Maybe there could be a few more which I am not even aware of, right? So if you look at the market share, AWS comes at the top in terms of data science infrastructure, right? But AWS comes at a cost. We can use the free tier for demonstration purpose, but it is going to cost us a lot. Same way, even Azure is going to cost us, right? So for the learning purpose, we can show you a couple of use cases on how to do it on AWS. We don't have a Azure subscription, so it's difficult for us to show it in Azure. But as I said, it's the concept of machine learning as is important at the beginning. It's not what infrastructure you use, right? So today, if you are learning it on your local machine, which is a laptop, and tomorrow you go into an industry where they give you AWS, that learning curve is going to be very short. So within a couple of weeks, you would be very comfortable doing all the stuff that you did on your laptop on AWS. Same way in Azure, right? So infrastructure as such is not a bottleneck for us. Okay. the concept of machine learning, which takes a lot of time, is going to be the key area that we are going to focus on. But for sure, for us to show at least like one use case on how to do it on cloud, it would be AWS, not on Azure. Okay, we can include more and more, but then that would result in huge cost on for us, and that cost has to be passed on to the students, not necessary at the beginning stage. So the prerequisites required to learn data analytics is statistics and some concepts of math, especially probability. Okay, but most of us did not learn statistics in our school days, unless you have done a BSc statistics or MSc statistics, right? So it's unfair to expect people to have knowledge of statistics before coming to this course, right? So I told you at the beginning that we broke this course into multiple modules. The first module is Python as a programming language, and the second module is data analytics. So in this module, before we actually do the data visualization, we will cover you probability, we will cover you statistical concepts that we need to know as a data scientist. Then we go into the data visualization. Okay, so that module covers everything that you need to know as a data analytics person, right? So don't worry, everything is taught to you in this course in the data analytics module. On top of it, you can learn a lot of different tools. Like we use Python and Tableau, but you can learn other tools if you really want to. Okay, any other questions? Okay, we were a little over time, but anyway, it was a very interesting and interactive session. Thank you so much for your time, that too on a Sunday. Have a great time. Our team will reach out to you.
Thank you.
If you have any further questions on course details, please reach out to our team. Yeah, it was my pleasure. Thank you. Thank you.